Hope you all doing well. Today I am going to give some brief introduction about creational design patterns in the software engineering. So first of all, I would like to give some sense for you which I am going to talk today. Think of some kind of design blocks with you. Imagine if you follow some steps to put these blocks together in smart, efficient ways, so you can create awesome structures easily. Well, in the world of software, we have something like that, called design patterns. Those are like some kind of step-by-step guides for solving common problems in software development. So get ready to explore these design patterns and how they make software development in a simpler and smarter manner. Design patterns more popular in computer science after the book publishers named design patterns, Elements of Reusable Object-Oriented Software. This book was first published in 1994, and it's one of the most popular books to learn design patterns. The book was authored by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlissides. It got nicknamed as Gangs of Four Design Patterns because of four authors. In software engineering, a design pattern is a general repeatable solution to a commonly occurring problem in software design. A design pattern isn't a finished design that can be transformed directly into code. It is a description or template for how to solve a problem that can be used in many different situations. Being a software engineer, your purpose should not be only writing a bunch of code, but also to reduce complexity and taking care of code reusability as well. You will be expected to write a clean, elegant, bug-free and manageable code so that other developers can understand, and later, if it requires any kind of change, then it can be done with minimal effect on your entire project, and here design pattern plays a crucial role. By summarizing those, we can say that it makes code reusable, bug-free, and clean. It speed up development process. Easy to make the changes or modification. It can reduce common problems of developers. It improve object-oriented skill. Also, it is easy to understand the flow of code. Then we move to identify what are the types of design patterns. There are three design patterns as creational, structural, and behavioral. So in the instance, I would like to give a simple definitions for these types. Creational design patterns that deal with the creation of an object. Structural design patterns in this category deals with the class structure, such as inheritance and composition. Behavioral design patterns provide solution for the better interaction between objects, how to provide loose coupling, and flexibility to extend easily in future. In this presentation, I would like to mainly focus on the creational design patterns. A creational design pattern deals with object creation and initialization, providing guidance about which objects are created for a given situation. These design patterns are used to increase flexibility and to reuse existing code. Here I am going to discuss four creational design patterns as singleton method, factory method, abstract factory method, and builder method. Singleton pattern. It ensures that a class has only one instance and provides a global point of access to that instance. In simpler terms, a singleton class allows us to create a single, unique object instance of that class. Singletons are commonly used for managing resources that should be shared across an application, such as configuration settings, database connections, or caching mechanisms. They are also useful when we need a single point of control for actions, such as logging, where you want to maintain a consistent log across your application. So these types of use cases can be mentioned under the singleton design pattern. Factory method. It creates objects with a common interface and lets a class defer instantiation to subclasses. As uses of this design method, first I can mention that when designing libraries or frameworks that provide a set of related interfaces, but the actual implementation can vary, the factory method pattern allows users of the library to create instances of objects without knowing their exact types. For example, in GUI libraries, we might have a factory method for creating different types of UI controls. Also, we can use this method when we need to produce variations of a product without modifying the client code. In unit testing, we can use factory methods to create objects for testing without directly connecting the real objects. This allows us to isolate and control the behavior of dependencies. In game development, the factory method pattern can be used to create different types of game entities, characters, which allowing for easy expansion and customization of the game. Abstract factory method. It provides an interface for creating families of related or dependent objects without specifying their concrete classes. As uses of this design method, first I can mention that abstract factory is often used in software that needs to run on multiple platforms, example Windows, macOS, Linux, and provide a consistent look and feel for the user interface. This allows us to switch between different database systems without changing your core application code. It provides a way to create and inject families of related objects or services into a client class, helping to decouple the client code from specific implementations. Builder method. It separates the construction of a complex object from its representation, so that the same construction process can create different representations. As uses of this design method, first I can mention that the builder pattern is used when we need to create a complex object that involves multiple construction steps. Also, if we want to create different variations or configurations of the same complex object, the builder pattern allows us to do so without duplicating complex construction code. Then we move to a real-world example to understand these concepts further. Think of a Pizza Hut where there is only one oven available for baking pizzas. The singleton pattern ensures that there is only one instance of the oven in the entire pizzeria. It's like making sure there's a single central place for baking all the pizzas to maintain consistent quality. Imagine a pizza chain where you can order different types of pizzas: margherita, pepperoni, veggie, etc. The factory method pattern is like having a menu that defines the types of pizzas you can order. When you choose a pizza, the specific pizza is created for you based on the recipe in the menu. Suppose that the customers can create their own custom pizzas by selecting various toppings, sauces, and crusts. The builder pattern is like the process of building a custom pizza. You start with a base crust, add various components, toppings, and finally, you have your customized pizza. Now, extend the pizza scenario furthermore. You have the choice to order not only pizzas, but also drinks like Coke, Pepsi, or iced tea. The abstract factory pattern provides a way to create families of related products, ensuring that the selected pizza and drink are compatible with each other. So this is some kind of real-world example which engages with the creational design patterns. As we conclude, let's remember that software development, like pizza making, is both an art and a science. I hope we can identify that design patterns are the secret sauce in creating efficient software. Much like the satisfaction of a perfectly baked pizza, well-implemented design patterns lead to satisfaction and success in your projects. Keep coding, keep innovating, and remember that every software problem has a pattern waiting to be applied. Thank you all for your time and attention. Don't forget to like, subscribe, and comment your valuable ideas.